Right, here we have another problem, another right angle triangle. Just write out the ratios. Remember the ratios are so, ka, to. So now we need to decide which ratio do we use. Pause the video and attempt the question. Which ratio do we use? So of course, the question was to find the value of A, by the way. Find angle A. It's an angle. Alright, so find angle A. That's what we're being asked, right? What's the size of angle A? Now, can Pythagoras theorem be used? No, it can't. Pythagoras theorem is only used to find the length of unknown sides on a right angle triangle, and therefore it's not practical in this case. Alright, so we have to use a trig ratio. But which one do we use? And again, just look at the information that you're given before you make your decision. Notice is not something that we have to guess. Notice angle A, that's the angle we're referring to. So, what does the 12 represent in the context of opposite, adjacent, and hypotenuse? Okay, correct? The 12 is opposite to the angle here, so the 12 is the opposite. And of course, this is our hypotenuse, the side which is opposite to the right angle. So we are given the opposite and the hypotenuse, and therefore we will use the sine ratio. So using the sine ratio, sine of angle A is equal to the opposite, which is 12. So we're using the sine ratio here. Opposite, which is 12, over hypotenuse, which is 25. So sine A, now what's 12 divided by 25? That's 0.48. Now how do we get the angle? How do we get the size of angle A? So you will use your calculator. Get your calculator out. Clear. Make sure it's in degree mode. So some calculator use shift, some calculator use second function. So you'll press your second function, then your sine, or shift, then sine, then in bracket you put 0.48, close the bracket, punch your equal sign, and I am getting 28.7 degrees to 1 decimal point, right? From using 1 decimal point. So 28.7. So the angle A, the angle here, this angle here is 28.7 degrees.